Okay, at this point, let's answer a few more problems. In the previous video, we finished one question on case 3, projectile fired at an angle in a certain height. So here, for number 2, sorry about that. Let's start solving. Okay, so it was mentioned here that it will take 10 seconds for the object to reach the same level by the moment it was launched. So I am thinking that although the surface is here where it will land, like where the object will actually land, from here we can derive that the time going up and the time going down, such that the time going down is only equal to the surface where the projectile was fired. The time going up can be said to be 5 seconds. But then the time going down, accounting for this region, it's not equal to 5 seconds. But at least that's going to be helpful for solving other stuff later. What else do I have to say? To reach the same level at launched, 100-meter building. Okay, I think everything's good. Yeah. Normal protocol. Okay, so that's kind of funny. This is already VIY for some reason. Usually, in the previous question, we were given an initial velocity, a VI, not a VIY. And that's still different from the VIY. So that made me think that I had to compute for another VIY. But this was entirely unnecessary. I guess that's not how it works. This is already VIY. So I doubt that this is the VIX or the VX. So what went wrong with the distance going up? VIY is supposed to be 49. So if that's the case, what does the calculator say? It's 122.5. Okay, so what is the final velocity of the object? I suppose this is, in other words, we're supposed to look for VFY going down. But in the meantime, distance going up. Is it correct? Yeah, it is. So we got it correct now. 122.5 meters. The distance going down is 122.5 plus the height of the building. So that is 222.5 meters. The time and the final velocity going down, we don't know yet. Let's now compute for the final velocity going down. So G is equal to VF minus VI over time going down. But we don't know what time going down is. So I guess that's not a formula that we could use. Something related to distance, since we know what the value of the distance is. Okay, good. I thought I was speaking to no one. So VF raised to 2 minus VI raised to 2 over, what is this, 2G. Okay. Distance is then equal to VF. VF is our missing value, the VFY. VIY is 0 meters per second squared over 2 times the gravitational acceleration going down. It's positive, so positive 9.8 m over s raised to 2. Distance, what is our distance? 222.5. Okay, so 222.5 times 19.6 is equal to 4,361 meters over seconds. Meters per second. And for VFY, you write it as just like this. Okay, what is the square root? That is 66.03787 meters per second. Okay, C where am I? Final velocity. Yes, 66.03787 03787. uh, VI and VIX. That is the last thing that we were tasked to find. But what are the other values that were mentioned in the answer key? This, and this. I guess the VF, this one a while ago, in the previous video. I suppose this is the velocity upon impact. I think it makes sense. VF, velocity upon impact. So I think we already answered for letter C. Let's see if we could find VF. What else? VIX, VIY, and the VI itself. I think VI is, yeah, it's different from the VIY a while ago. VI is equal to velocity upon launch. It doesn't relate to either the X or Y axis. So yeah, there's a significant difference between VI and VIY. VIY, since it's Y axis, I suppose this is the vertical velocity. For VIX, that is the horizontal velocity. Please correct me if I'm wrong, but I'm pretty sure I understand it correctly. Horizontal pertains to the x-axis, so yeah. VF, VI, and VIX, and VIY. Well, we already know what VIY is. So let's just look for VIX. Okay, what do we start with first? VF is going to be hard. Let's try VI first. So VI is missing. By the way, these are not related to letter C anymore. So from the formula, VIY is equal to VI sine theta, such that theta is 45 degrees a while ago, and VI is missing, and then VIY, we know the value already, which is equal to, where is VIY? 49 meters per second. So what do we do? How do we separate VI from the rest? It has something to do with arc sine something. I'm not sure if dividing both sides by sine 45 is allowed. It doesn't feel right. but let's do it anyways. So 49, I think it is okay. 49 over sine 45 is equal to 69.29646, and then the unit is in meters per second. So that is for VI. For VIX, how do we compute for VIX? Now that we know what VI is, VIX is equal to VI cosine theta. And VIX is missing. VI is, I know that this decimal form, if you see it in the calculator, you get a value of 49 times square root of 2. Let's just use that for complete accuracy instead of the rounded off decimal version. And then the theta is 45 again. What is the answer? So the answer is had to be 49. I'm not sure if it's a coincidence for VIX to be equal to the same value as VIY earlier, which is had to be 49. Wait, the unit. I almost forgot. Okay, and for VF, VF is equal to what again? There's a formula for that. VF is equal to VFY over VX, if I remember correctly. Hopefully, yes. No. Wait. Sorry. I messed things up a little bit. The angle at the time of impact. Angle at time of impact. So this is tan theta is equal to VFY over VX. And then the velocity upon impact, VF, this is equal to, well, VF squared is equal to what? Okay. So there's a stark difference between these two formulas. One is velocity upon impact, one is angle at the time of impact. But essentially, the ingredients are the same. They're just positioned in a different manner. Wait, where is that? So VFY raised to 2 plus V of VX raised to 2. VFY. Okay. Okay. So far so good. Okay. Now that we know this is raised to 2 VI. Is it VI? No, VX raised to 2. So first things first, what is VFY? It is said to be 66.03787. We are using the VFY going down. Since this is associated with velocity upon impact. And Vx is what? Vix. So again, the formula Vix is equal to Vx, simple as that. Vx is therefore 49. Didn't write the unit again. Okay. And then place a radical sign immediately. What is the answer? So Vf is equal to 82.23138 meters per second. So did I get these values correctly? So let's start with VI. VI is 69.29, VIX is 49, VF is, well, I got something's wrong with VFY. No, never mind. 82.23, never mind. Yeah, everything's good. Oops. VF is again velocity upon impact. VI is velocity upon launch, and the reason why a while ago um, this sorry, where is that? The reason why this value is supposed to be VIY instead of just being VI is because we used ingredients that were related to the projectile going up. For instance, the gravity. That's gravity going up, the time going up, the VF going up. So therefore, the VY is naturally supposed to be VIY also. The VI going up. It is not the same as the velocity upon launch. We find that once we can do something like this. We know VIY or VIX, and then we know the angle. Okay, next. Okay. This is gonna be pretty easy, this part. We still have one last practice exercise for projectile stuff. Nothing too hard, I guess. But I just need a lot of space. Okay, case 1 projectile problem. Projectile fired horizontally. So the velocity in the horizontal direction, what is this? V what? Horizontal. So Vx will never change. Is it Vx? I'm thinking Vx is horizontal velocity. And dx is the horizontal displacement, as stated earlier in this video, or in the previous video. So, a tennis ball is rolled off the edge of a 75-meter building. So let's say this is the building they were talking about. Okay, so the height is 75 meters. Horizontal velocity, what is that? Vy 10 meters per second. 10 meters per second. What is this, final or initial? I'm not sure yet. So, VFY is missing such that the time is 3 seconds. We are not given like a situation where there is a going up. It's only a matter of going down. The tennis ball from the top of the building goes down. So I'm thinking that the VIY is therefore 0 meters per second. Although it was rolled off, there wasn't, I don't think there's force applied when it was being thrown off the edge of the building. I mean, rolled off, not thrown off. So VFY is missing. we do know what the Vy is, horizontal velocity. Wait a minute. No. Is this the initial velocity? If that's the case, then there should be a force at the beginning of the projectile. Hmm. Okay. Alright, I'm gonna need some help in this part. Okay. I guess not. Looks important. Velocity upon impact. It has something to do with the triangle, such that the angle upon impact is the one with tangent theta equal to Vfy over Vx. And then here we're looking for Vf, velocity upon impact, which is the hypotenuse. Okay. Based on my notes, yeah, Vx doesn't change. Oh, I seem to find the problem. Horizontal velocity is supposed to be Vx. Literally, it says here, the velocity in the horizontal direction will never change regardless of the time. So still, Vx is equal to 10 meters per second after 3 seconds. Okay, next, sketch the path that the ball will take as it leaves the top of the building. Well, I suppose it's right to say that Viy is still 0, and Vfy is missing. But the gravity, we do know that it's 9.8 meters per second squared. Distance, still 75 meters. Okay. So, yeah, letter B is this one. Do we have to label the values? I don't. You know what? Let's just do it anyways. So Vx, the path of Vx is constant to the other side, and Viy, and then Vfy is somewhere here. And then let's say the time here is 3 seconds. The reason why the Vx is never going to change, just imagine that there's no gravity. If there's no gravity, then the object will never go down, will never be pulled downwards to the surface of the Earth. So if that's what happens, then the Vx, the ball will just constantly move along the Vfx direction. So yeah, wait, is velocity scalar or vector? It is a vector quantity. So there is a magnitude and there is a direction. That's why it says here the direction will never change. If that's speed, then there shouldn't be any direction. But in this scenario, we don't really have speed. Okay, so The velocity in the vertical direction will change due to the acceleration of gravity. Yeah. Blame gravity for the variability of the vertical velocities. So yeah, we have the same scenario. Let's just copy paste the given. What is our direction? Sorry, the distance. 75 meters. Okay. What is the ball's vertical velocity after 3 seconds? So yeah, given the time that it is 3 seconds, um, let's use this formula. So gravity is going down, so it's a positive value. Vf is what? That's the missing value. Vi is 0. What is the time going down? 3 seconds. So 3 times 9.8, 19.16 plus 9.8, 29.16. Screw it, I'll just use the calculator. So it's 29.4. So that is, I suppose, the velocity after 3 seconds. Let's see what I have. Okay, I have a different. Yeah, I don't really. There's no answer key for that. Okay, free fall kinematic formulas. We've been using this. How have we been using this? Vfy is equal to Viy plus gt. Really? What the? dy is equal to Viy times the time plus 1/2, or just gt raised to 2 over 2. Yes, yes. We've been using this. Vfy raised to 2 is equal to Viy raised to 2 plus 2g times dy. I think this is just another way of saying g is equal to v. No. Distance is equal to Vf raised to 2 minus Vi raised to 2 over 2g. To g dy is equal to, I'll just add Vi y here and then Vf. Yeah, they're essentially the same formulas. But this one I'm kind of curious of. Vfy is equal to Viy plus gt. Have we encountered this before? I suppose so. Let's see. G is equal to Vf minus Vi over t. Oh, yes. Gt is equal to, Gt plus Vi is equal to Vf. Yeah. We've been using those kinematics formulas. But yeah, these are just written in a different way. But they're essentially the same with the ones that we've been using since day one. Horizontal direction, average velocity formula. Vx is equal to dx over the time total. We've been using this since a while ago also for the horizontal displacement. Okay. Yeah, if you want to list for the x direction and the y direction, This is our horizontal. Wait, no. That's our list for vertical. If you want to formally write down the horizontal values, remember that Vx is always constant. Vx is what? Well, you just have to write the Vx value, the dx, as well as the time total. There are only 3 values under the horizontal. If you want to make a table for that formally. And for vertical, as usual, we've already made a table about it. Vfy, Viy, G, D, and T. So, let's try number 3. A plane flying horizontally. So, let's say this is a plane. At an altitude of 490 meters. So the altitude is basically the height. And having a velocity of 250 meters per second east. It's kind of slow, to be honest. Or wait, never mind. It's kind of fast. Drops a supply packet to a work crew on the ground. Falls freely without a parachute. Assume no wind and air resistance. Sketch a path of the supply packet after it leaves the plane. I think this is how it works. Is it? Well, yes. Horizontal. Why is this the horizontal velocity? It says here horizontally. So determine the time required for the packet to hit the ground. So let's make a table. So this is horizontal. This is vertical. F y. The final velocity is at its maximum, somewhere here. How about the VIY? That is 0 meters per second, I suppose. Yeah, that's only for the horizontal velocity. But you know, the package is supposed to move like in that direction, but then it goes down. So it's a hyperbola. It's a hypotenuse. Because of gravity, basically the trail going down. But then for VIY, the initial vertical velocity is still 0. And then, yeah, it's influenced by gravity. That's why it increases in the final velocity, vertical. So gravity is still negative 9.8 meters per second squared. Distance is 490 meters. Time is what? Well, that's the one we're looking for. And dx. Why do we keep saying d of x? That's something related to calculus, pre-calculus, and trigonometry. Time total, well, it's still the same time as this one. Dx is what? Dx is basically this to this. From when the plane released the package to the area where it starts hit the ground. So let's try G is equal to VF. No. We do have distance, so VF raised to 2 minus VI raised to 2 over 2G. D, which is 490 meters, is equal to the VFY, which is missing. VIY is 0, so let's just disregard that. 2 times negative 9.8, that's negative 9.16 meters per second squared. 490 times 19.6 is equal to what? Negative 9,604 meters squared over second squared. Oh wait, no. This is gravity going down, so it's supposed to be positive. What was I thinking? Because if you try to square root a negative value, that's gonna be an error. Okay, so what is the square root of 9,604? It is said to be 98, and then the unit is going to be in meters per second. That's not the final answer yet. So, looking for the time, let's try to use this formula. So what is the gravity? That's 9.8 meters per second squared. What is our VF? VF is 98, such a clean number. VI is 0. Time going down is missing. So we have 98 meters per second divided by 9.8 meters per second squared. Time going down is equal to what? 10 seconds. So are we correct? So yeah, we found the time. It's 10 seconds. Let's look for C. What we have for letter C. Determine the horizontal distance from the target area that the plane must drop the packet. Okay, what is this? Horizontal distance. Okay, so that is d of x. We do know that the formula related to dx is vx is equal to dx over time total. And what is our vx right now? It's said to be 250 meters per second. I can't believe the given is kind of generous. Let's say that we don't know what v of x is. Vx is. So let's say vix is equal to vi sine theta. Do we know the angle going down? We do not know that. Okay, so never mind. Either way, we won't be able to calculate without the angle. And the vi, which is the velocity upon launch. We need those two values to find vx, but vx is already given anyways. So what is the total time? That is 10 seconds. Multiply both sides by 10. 250 times 10 is 2,500. Cancel the seconds. So the horizontal distance is said to be 2,500 meters. Let's see if the answer is the same as my notes. Yes. Okay. Nice. We still have how many problems? One last problem before I end this video. Another one will be for free body diagram. And after that, we're not free yet. This is, related to free body diagram again. And after that, we're free. Like, literally free. I'll be moving on to the other subjects that I'll be preparing for. Physics is not the only entrance. No, it's not the only quarter exam that I'll be taking. I do have biology. Yeah, that's the only subject that I'll be posting here. Other subjects, I don't teach those. I'm interested in recording what I understand for science and math, essentially. So Number 4, a ball is rolled off a table at 5 meters per second. I suppose this is the horizontal velocity, because even before it starts to fall, that is already the velocity. And what is that related to? Before it starts to fall, that's something related to the horizontal aspect. Hence, Vx is 5. If the table is 1 meter high, so let's say this is the table, 1 meter high. Then determine the time it takes for the ball to strike the ground. So time going down is missing, such that Viy as usual is going to be 0. Vfy is going to be at its maximum value. And we know that the gravity is going to be 9.8 meters per second squared. So how do we calculate for the time? We do have a g and then Vf minus Vi over t. 9.8 meters per second squared is equal to Vf. Vf is, we don't know it. Vi is 0. Time is, well, we don't know it too. But we do know the distance or the height of the table, so let's use the distance formula. Distance is equal to Vf raised to 2 minus Vi raised to 2 over 2g. T is equal to Vf. Vf is missing. And Vi is 0. So just disregard that. 2 times the gravitational acceleration of 9.8. What is going to be the answer? Distance, we know it as 1 meter. So multiply both sides by 19.6. That's going to be 19.6 meters squared over second squared equal to Vfy raised to 2. So find the place a radical sign on both sides. What do we get? We have 4.42719 meters per second. That's not the final answer yet, though. It's important to find the time using the gravitational acceleration formula. So what is the gravity? That is 9.8 meters per second squared. Vf is 4.42719 meters per second. Viy is 0. What is the time? That is what we're looking for. So 4.42719 over 9.8 is equal to 0.45175 seconds. Okay, so we have the same thing. Wait, why did I draw a tree here? It says table, but I drew a tree. That's just weird. Okay, so what is the vertical velocity of the ball just before it strikes the ground? It pertains to vertical, so y-axis. So Vf, it says just before it strikes the ground, so that's definitely final. So Vfy is the one missing. It's a value we've already calculated for a while ago. So let's see if it's correct. 4.42719. Or yes, 715. So how far horizontally from the edge of the table will the ball land? So horizontally, so dx is missing. It's kind of crowded here. My illustration is not presented clearly, but then basically this is the table, so it's 1 meter. This is the dx. So this is what we're looking for. Projectile going down. So using the formula Vx is equal to dx over total time, dx is equal to Vx times the time. What is Vx? So Vx is 5 meters per second. What is the time total? It's said to be 0.45175. 5 times 0.451175 is 2.25875. Okay, yeah, so far so good. So what is the horizontal velocity of the ball just before it strikes the ground? Did we already calculate for that? No, never mind. This is horizontal, so VFX or VX. What is VX? No. Wait, this is kind of weird. Just before it strikes the ground. Well, it's still the same as Vx a while ago, what was mentioned. Since it's constant, right? So regardless if it's already at its final or initial phase, it's still going to be the same as a while ago, which is 5 meters per second. Never mind. Wait, what? That's vertical velocity. Yeah, 4.42 something. But D. Well, yeah. Just exactly what I said. It's still the same regardless of the time. Okay, that's it. Next we'll be focusing on free body diagram. But so far, this is what I understand of. It's a good thing we've solved quite a lot of questions. So many. I'm planning to, in order to properly review for my exam, I plan to answer all of the worksheets that were given to us, and I'll make sure everything is correctly answered. And of course, the conceptual ideas such as which variable represents what part of the projectile. So basically, this page is going to be very important. I have to know each one for their definition. So there's no room for failure. Thanks for watching, and I'll see you at the next video.